Hi, everyone, and welcome to the Final Frontier podcast. I'm your host, Daniel Penaranda, and I'm joined here today with an exciting guest. He has a phenomenal background. His name is Mr. Bob Brumley. He is CEO of Laserlight, as well as Commstar. And today's topic, we're going to be covering Cislunar Space and its commercial applications. Bob, welcome. Glad to have you here. Before we jump into our topic, I'd love to hear a little bit more about your background and what got you started in this industry.
Thank you very much for the invitation. I appreciate it. I'd really wish it was called the Next Frontier podcast, not the Final Frontier, given my gray hair, but I will accept it. What gets anybody involved in this industry is, a combination of what you're exposed to early in your career. I've got a long career, and quite candidly, it did not include engineering or space-related topics. I served in the Reagan administration, and I happened as a collateral assignment there take on a responsibility on what was the Commercialization Space Working Group for the National Security Council and the Economic Policy Council. Sounds like a lot of jumble of government speak, but in 1984, 85, 86, there was a big debate within the administration, which included NASA, that NASA needed to basically step aside in some respects and allow the private sector to come in and essentially provide services. Seems pretty common sense today. It was emotional in the 80s. It took 34 years to implement what President Reagan announced, which was the fact that commercial space transportation would be the preference that NASA would use instead of their own owned and operated vehicles. And but without that policy, you wouldn't have SpaceX. You wouldn't have any of the other startups that failed. And you wouldn't have the success stories that you have right now, what we've seen. But 34 years to commercialize transportation is too long. And so now you're seeing a shorter time frame because of the pressures for the private sector, especially since 2015. And I've sort of been caught up into that. This is my Laserlight. I'm the CEO of Commstar. Actually, I'm the chairman of the board for Commstar, not the CEO. And that would be my fourth and fifth satellite venture. I have done three others, TerraStar before this. It is not like eating peanuts. You think you do one, especially as long as they take to do, and that would be your life's work. And I've got five, so that's kind of interesting. Technical background is that helps me in this business is essentially the ability to look at the value proposition in these business cases and look at their ability to basically attract outside capital, ability to return on their investment, ability to pay their debt back, and the ability to scale. And so you don't have to be an engineer to be in a space program. You could be an MBA. You could be coming out of school with basically like me. I had a political science background, then I went on to law school. So there's room for this sector for basically anybody from any walk of life who is excited about it and tag on to what would be, a startup company or an established company, because as a business sector, they need all capabilities, strengths of like the automotive sector. Today, it's AI, robotics. That's as true in space as it is in autonomous vehicles. So that's a long-winded answer how I got here, but I'm here, and I have to admit to you, it's been a wild ride. It's been a lot of fun.
And that's really incredible. I think your perspective, even working with the administration is incredibly valuable. So you've seen firsthand the shift between government to commercialization. What do you think is one of the biggest pressures why we had to make that shift?
It came down to whether or not you believe that space was a business sector or space was a function of government. That debate's still going on right now, but I think it's over with. If you talk to Morgan Stanley, it's $1 trillion market by 2030. You're not going to keep the private sector out of a $20 trillion opportunity. On the other hand, government budgets, if it's $1 trillion market, compare that to NASA's budget of less than 100 billion a year. It's scale, and it is the launch costs have come down. So it's cheaper to get a kilogram to space in low Earth orbit, for example. 3D printing has been around now for probably about 7 or 8 years, beyond just doing testing on the ISS, but now actually real 3D printing opportunities that would be in low Earth orbit. The ISS has proven it's expensive, but it's long duration worth, in that NanoRacks is a commercial example. It's sitting on the same platform that the government owns, and yet it's commercial. So it's proven over time that commercial can work side by side government and not distort anything. And then after that, when capital finds an opportunity, it usually flows to it. And I think the combination in the last 10 years has been small sats, skybox imaging, for example, which is now, I think, Planet. SpaceX, obviously, and cost of transportation, but smaller launchers like Rocket Labs and Astra and others that are bringing the price per pound for smaller payloads. The proliferation in LEO, good or bad, crowded or not crowded, the debate really is the fact that there's a lot of money going into LEO for certain services. But if there's really one big thing, in my opinion, it is the average person, irrespective of nationality, the average person now can relate to receiving goods and services from space. And before that, only science agencies, universities, government, and maybe downstream big aerospace companies got the benefit. But if you can actually log on to a Starlink or a Kuiper or a Lightspeed or another type of platform and get your daily internet and not care that it came from space, or it came from a copper cable, or it came from a fiber optic cable, or it came off a 5G tower, because you're just paying $79 for a service that you like, that is a huge breakthrough, because now it normalizes space as a sector, as a real business sector, and then capital is comfortable to flow into it.
Absolutely. And to your point that, lower orbit is quite crowded and near space is quite crowded. And part of that's credited from the government shifting to perspective of colonizing the moon, or doing a lunar exploration and moving more towards near Earth applications. So the International Space Station, as well as the space shuttle. Why did we decide to recede back, and what's going to take us forward to go back there?
Well, returning to the moon, our closest orbiting physical item around us. Forget the Jules Verne part of it and the science fiction part of it, and the fact that we went to the moon and proved that we could do it, as Kennedy said, because it was hard, and it was a technology demonstrator, if you will, of the highest kind, and it has stood as a test of time. Gee, if we can put a man on the moon, we should be able to fill in the blank, right? The challenges we have on the Earth. That becomes a model for exceptionalism. And then not just necessarily only American exceptionalism, but the exceptionalism of science and technology that is aimed at accomplishing a goal. So why we go back to the moon, there's part of that. But I think the practical reasons, if you were talking again to Morgan Stanley or someone else, going back to the moon because you can make money doing it. You can make money on transportation. You can make money on habitation. You can make money in communications. You can make money on mining. You can make money on industrial development. You can make money on essentially travel and tourism. If you can export that, remember the guy with the internet who doesn't care that it comes off of space. There's also people who really want to move onto the lunar surface and do things that we do on Earth, that we do there, which establishes basically business opportunities. The long-term strategic interest in the moon, I think everyone has said, is a staging area to go to Mars. And so fuel, I heard a podcast the other day saying something like, I'll get this wrong, so I'll say high percentage of the weight of a launch vehicle is the weight of its fuel. And so if you can actually use the moon as a logistic hub, that place where we refuel with fuel that is created on the moon, that's developed from resources on the moon, that allows us to then more efficiently go to Mars, then the moon is really, it's really strategic for everybody. But on top of that, the moon has an estimated series of heavy metals and other things that would be of value back here on Earth as a consumable. It's also an interesting position for a variety of, we're going to have to think about defending this planet at some point from asteroids and other events like that. And the moon would be, just looking at the moon topography right now, it seems to absorb a lot of hits. Using the moon as some kind of tracking station, early warning station, or something that gives us 240,000 miles, gives us a little bit of advanced warning on something we may not pick up in the deep space network. So for all those reasons, but in the community that I'm in, it is, the moon provides the next economic opportunity. Call it a gold rush or a moon rush, if you will. The next economic opportunity for humankind to basically extend itself economically, operationally, engineering standpoint, to off planet. And of course, the moon is off planet.
And many government, the government as well as companies are looking to move towards cislunar space. Could you describe what cislunar is?
Yeah, my personal description is that we look at the Earth and the moon on a flat piece of paper. There's a circle over here, and there's a really pretty little blue and green thing here, and then we draw lines between the two of them. It's really not that. To me, cislunar is like a sea. In fact, I call it the Cislunar Sea. I don't take credit for that. It's just, to me, it's a sea, and you're not above it. You're not below it. You're in it. You're moving through it, and as you move through the Cislunar Sea, you have to adapt to all of its gravitational aspects, all of its environmental aspects, radiation, etc. What's neat about it, and for your audience, is just to be clear, is that there is what we always referred to as near Earth. Okay, the near Earth orbits were LEO, low Earth orbit, MEO, medium Earth orbit, and GEO. GEO is where all the big heavy Comsats are, and your direct TV and things like that. LEO is where Starlink and others are, low Earth orbit. That really now, that definition of near Earth has sort of moved now out to 2 million kilometers. NASA has redefined near Earth to be the other side of, say, the moon by quite a distance. There's still deep space, which is past near Earth. And so instead of calling it near Earth, NASA calls it near space and deep space. So the space between near Earth and the near side of the moon is called cislunar. It's the space in between, the fill, if you will, in between. On the other side of the moon, the far side of the moon, on out to deep space, is translunar. So you have, when someone says, I have a business idea, question one is it in near Earth, or is it in cislunar, or is it translunar, or is it deep space? So those are kind of the three playgrounds, if you will, the three C's you might want to talk about. Why that area is of interest? First of all, it is the physical space between the Earth and the moon, which means it's a transient space. It's a place that you have to transit to get to whatever you want to get to in the moon, or possibly even in translunar or in deep space. A lot of traffic going back and forth is anticipated there. Secondly, it is, when you look back at the Earth from a situational awareness, it is the high ground. Now, the high ground is misleading because there's no height and depth, but speaking strategically, it is an outer position that gives you the ability to observe, detect, track, locate, and log activity that is originating on or around the Earth. And from a standpoint of space and time, that is strategically important. So if it takes at general speeds that it's going to take you 2 to 3 days to get to the moon from the Earth, if you're only 30,000 or 40,000 kilometers from the moon at L1, Lagrangian point number 1, you're sitting there, means that you've got a 48-hour period to see what is coming this way. And where did it originate? Who is it? So there's a security and surveillance aspect to that. So you start looking at this not as space, but as who has jurisdictions relative to services. And of course, you have security, which looks at tracking, tagging, and logging. You look at environmental, which looks at situational awareness, but that's also security. You look at what would be the need to provide services. So you have equipment, technology that is deployed in this area that has to be built to be capable of operating in a much harsher environment than it would be in near Earth. And then you've got to have essentially technologies that relate to the lunar surface, that relate similarly to our lunar surface, our Earth surface, such as caching, compute, and the capability to do streaming off the lunar surface of communications or robotic management or industrial machines. So when you add all that up, everybody is floating in the Cislunar Sea. And the first thing you got to do is you got to prepare to be in that sea, operate effectively in that area, and then be able to provide whatever service, military, diplomatic, governmental, commercial, that actually is what you're applying your investment dollars toward.
And I think that's an incredible description. And to your point, do you think the government is driving cislunar development, or is it more coming from the commercial side?
Well, I think you've got you have a definitional issue here. Both NASA and ESA and JAXA and the Chinese and the Indians, to speak of just the majors, are driving lunar development. They all have a return to the moon program. The private sector supports that program as vendors to government, but the private sector also is looking to go to the moon for the first time as private companies. So when you go to the moon the first time as a private company, you look at it a little different and you start breaking things into sectors. And so one of the sectors has to be, I'm not necessarily going to go on the lunar surface. I'm actually going to be in transportation. So I'm going to be transporting from the Earth to the moon. What am I going to be doing? I'm going to be transiting cislunar. What's cislunar? Well, cislunar is this space in here. What are the challenges, et cetera? So I have to build for that. I'm going to communicate and haul, relay communications from the lunar surface back to the Earth, or from the Earth to the lunar surface. I have to go through cislunar. What does that mean? And so in a sense, it's only a recent phenomena that people are sort of demonstrating they're in the know, that they can say, hey, I'm in cislunar. Well, then so podcast after podcast, one of the things I am an evangelist about is understand what cislunar is. It's the near side of the moon. It's not the lunar surface. The lunar surface, or returning to the moon, is a physical act of either going in orbit around it or else actually physically being on the lunar surface. But understanding, again, all the aspects of trying to operate in that cislunar sea is really important for you to be able to go from the Earth to the moon and be successful.
And what could be made possible in cislunar that you can't do in near Earth space or in transient lunar or further beyond?
You have to work backwards from the customer. Okay, that's pretty simple. And if the customer is on the lunar surface, then what's the relevance of products and services that you can provide that may require you to be in not lunar orbit, which I distinguish from actually cislunar. It's more specific, like near Earth orbit, but outside of that orbit. Now that means if I'm an investor and we want to do mining on the moon, okay, we're going to go on the lunar surface, but it's going to almost be entirely robotics. So consequently, how am I going to run the robotic systems? Well, I can store forward robotic commands like we do on Mars and other rovers and that sort of thing, or I can try to real time combine store forward with low latency upgrades to do what would be lunar surface computing. Now, to do lunar surface computing, you've got to have a stable connection. You've got to have, in this case, it's going to have to be line of sight. And that means you're in Cislunar. So now, where can I find a place that's stable, somewhat, I don't have to go around the moon and lose connectivity by losing line of sight, or else have to put a bunch more satellites up. So how can I do it in a way where I can manage what would be the compute functionality of, say, the development of industrial development on the lunar surface? I can go backwards. How far back? 200 milliseconds? Okay, that's reasonable in the Earth. It's not a high-speed gaming link, but it is reasonable, more than reasonable, for robotic management on the Earth, on Earth mining. So where would that put me? 200 milliseconds puts me at about a highly stable point called Lagrangian point number 1. At Lagrange point 1, it's stable. As the moon and the Earth chase each other around, this one little point chases it with it. And so it stays generally all the time line of sight to the near side of the moon and line of sight to the near side of the Earth. And it's, from a standpoint of stability, it uses less fuel. There's less jitter on the satellite. There's not a need for that much buffering. That's a really stable point to do high-speed data communications to a fixed point on the near side. And that's what Commstar is going to do. If you're doing data relay, then you can be closer to the lunar surface. But then you've got your satellites. There's 3 or 4 really decent orbits around the moon. And as a result, you're going to have a number of satellites that look at each other, and then they have to relay back. If you overbuild those satellites, meaning build a lot of SWAP, space, weight, and power, then you can go direct to Earth. Not only at better than kilobits, but you can go to direct to Earth maybe in gigabits. If you add optical telescopes to it, then you can also go direct to Earth at gigs of optical links. The problem is that's a lot of space, weight, and power that you're going to have to build into these systems, and they're not as stable. There is more what you would call instability in the lunar orbit, and it has some effect on what would be the quality of the comms. So if you connected the comms to, say, us or to someone else who's stable, then they can relay it, and you don't have to have as much swap, which means you don't have to spend as much money. So you go, it's a little bit like carrying a cell tower on your back all the way to the lunar surface. If you have hybrid relays, you don't need to do that. So that's just one example. And not to make this just about Commstar, there's Moonlight, which is ESA's constellation. There is Pathfinder, which Surrey Satellite is building, which is in an elliptical orbit around the moon. Partly, I think, I don't know for sure, but it makes sense to me from an engineering standpoint to get away from the moon lunar orbit and then swing back in and constantly being able to see that near side of the moon. That gives it more stability while it's moving through Cislunar. So you're seeing Cislunar designed solutions, but why are they being designed? Work backwards from the customer. The customer needs a certain level of communications, a certain level of software management, and a certain level of caching, store forward, and content delivery that a standard satellite, RF satellite, isn't going to bring while it's just orbiting around the moon.
I think as the investor in the capital markets acceptance of Cislunar, are they more willing to take the risk as well, or do you see that they're still a bit risk adverse in terms of relinquishing their capital to support these startups?
Yeah, I think the misnomer here is that the past is really a good indicator of the future. No one invested in the Atlantic. They invested in ships that could cross the Atlantic. And they were investing to get on the other side to be able to do whatever they wanted to do, fur trading, developmental, religious freedom, whatever. We're not investing in Cislunar per se. We're investing in a communications capability that has the capability of connecting the moon and as well as the Earth for a variety of different user and use cases. We happen to be in Cislunar, just like the Mayflower happened to be in the Atlantic. That does not mean, from a security standpoint, there are those who want to plan for and investigate and surveil the Atlantic, in this case, Cislunar. So you could have national security assets in Cislunar to monitor activities. You could have, of any country, you could have environmental assets that are doing the same thing, space weather assets. I had a call from one space agency that was interested in deploying certain types of satellites that look at essentially EMT, electromagnetic pulse type activity that would come off a solar flare. And they wanted to know, could their sensors relay to Commstar, and Commstar in turn could relay to the Earth as an early warning system? The answer is, if they're using RF or they're using optical, it's an open architected satellite system. So the answer would be, yeah, if you can see Commstar, then you should be able to connect to it, and vice versa. So, but they're interested in Cislunar as an environment like the Atlantic, as a sea in which they would position themselves. So they're not doing business on the moon. They're really positioning themselves in that service area to provide what would be certain types of solutions to the Earth. And I would think that would be true not only of the US and European security and environmental groups and science groups.
Right. And an additional topic that we like to talk about during this podcast is what makes a great leader in this industry.
Oh, I think the ones I know and the ones I know of, but I've not met. I mean, for example, I've never met Elon Musk. What I like about him is the fact that he knows there's a linkage between breaking things and making things, and he's not afraid to break things. He's also gifted relative to being able to tap in on what appears to be an unlimited amount of capital. That's a great leader, and it reflects on the things that he's doing. Doing Tesla all by itself would have been a life's work. Doing Tesla and Solar City and his Gigafactory and the Boring Company and Falcon 9, which is incredibly successful, Falcon Heavy, which will be successful, and then Starliner, et cetera. I mean, it speaks for itself. The rest of us, not Elon, but the rest of us who basically are gritting this out and grinding it out, the ones I like are the ones who understand the fundamentals of what are we trying to do here. We're not trying to throw something up and then think about how we'll use it later. We're working backwards from an established understanding of what the customer wants. We have essentially an idea that in respect of both investor money and private money, debt and equity, we use it judiciously to deliver on what would be that service that the customer wants. And then we do it in a way that is both effective, ethical, and at the same time provides what would be, again, the service and the return on the investment for the customer. That's probably the goal of every entrepreneur, every innovator. They don't have to be a CEO. They don't have to have gray hair like me. They have to have a fire in their belly about doing something. And then they have to figure out how to do it and then raise money to do it. And they can't do it by themselves. I've never built a company by myself. You have to bring in not only a good management team, but you have to have partners, vendor partners. You've got to have a little bit of help from government. And I'm not talking about funding, but you got to have a little bit of help from government. 30 years ago, it was to get out of the way. Okay. Today, it's partnering, Space Act Agreement partnerships, SBIR, university agreements. The most successful, in my opinion, the most successful NASA program in returning to the moon right now is the CLIPS program, because there is the embodiment of what Ronald Reagan was talking about. You make a bigger difference by being a paying customer than you are as being a competitor. Bringing people along to say, this is my bus and you're allowed to get on my bus and go to the moon, as opposed to saying, you build a bus and I'll buy a seat and you take me to the moon is the entire difference. And the CLIPS program is a phenomenal, low cost to the taxpayer use of money that's stimulating an incredible industry of creative people who would not normally be competing for. I mean, they're not Boeing, they're not Northrop Grumman, they're not Ball, they're not Raytheon. These CLIPS partners are small and medium-sized startup firms that have been around, in some cases 10, 12 years, that are going to be the first ones. They're going to be there before Artemis is there. Astrobotics, Mastin, Intuitive Machines. These are real success stories, and NASA really should get a lot of credit for this because they've led the way here. ESA hasn't done this. I haven't seen the Japanese do it. I haven't seen the Indians do it. I haven't seen the Chinese do it. And I don't know if it was just something that NASA did in order to address what would be a demand that private sector companies should have a role in this. But whoever did it, it has worked. And because of those landers, Commstar's business case is in part based on what would be data relay from those landers. So they created a market for us. And if they created a market for us, and they also created a market for those who are going to receive this information. I'll give you an example. On one of the landers, we went through, there's two types of comms that the landers have. One is the lander comms for TT&C, tracking, telemetry, and control, and one is mission comms. Mission comms would be their payloads. Remember, they have customers. Their payloads would do whatever they do, and then they would send it back on RF through the lander. In our case, some of those payloads are going to use the lander for TT&C, and they're going to use Commstar for content. All of a sudden, wow, what does that mean? There is two markets for comms: connectivity, low throughput, kilobit traffic, and content. What is content? 4K, 8K video streaming. I've got a rover. I'm going to put a GoPro type camera on that's space qualified. I'm going to put it on the hood of the thing, and I'm going to drive it away from the lander, and I'm going to drive it in 360 degrees, and I'm going to park it, and I'm going to do all sorts of other things with it. And I'm going to continue to stream that back to Commstar, which will stream it back to the Earth. And I'm going to put it up on, say, maybe I will turn it into basically a video clip, and then I will license it out for eyeballs, and I'll make money on advertising, not unlike podcasts. So now you've got, if you can make money on Puppy Cam and Panda Cam, you can make money on Lunar Cam, and that's content. So content isn't going to change the world. What content's going to do is give a return on investment for some of these payloads that are going to the moon. There's also serious stuff like regolith investigation and industrial development and that sort of thing. But if you really look at the one that we see that as a growth avenue, it's allowing payloads to visually document what they're doing on the lunar surface, returning it to Earth in high quality video, not the grainy Apollo video, high quality video, and then put it out into the public space to do what? Drive advertising revenue, and it feeds on itself. Kids watch it, school, STEM, et cetera, and they go, I can do that. Why can't I put a payload on a lander and do that? The payloads are there because of the landers. The landers are there because somebody had the foresight in NASA to create the CLIPS program. The taxpayer has paid for the CLIPS program, and that to me is stimulating one aspect of business on the moon.
Absolutely phenomenal. And I can imagine the future, you rent out a lunar RC and drive it around. That'd be quite the day.
We have one potential customer who wants to have drone races on the moon. They small drones, space qualified GoPro type camera. They take them out, and they're going to go out, and they'll go around pylons, and they'll just run around and run around and run around. Point is, it's content. You're just in social media as well as business media, if you will, technical media. This is sort of the bridge from what would be exploration and exploration into development. And if you can figure out a way to make money doing this, and believe me, the world is full of people who can make money out of it. If they've got a connection, That's what our whole social media program is based on. They'll be able to make money on that. And then so we then go to the serious stuff. What did the rover with the GoPro camera prove? It proved that we can maintain a steady content stream back to the Earth. Okay, well, if it proved that, what do I need to basically do industrial development for regolith to be converted to a building material? You're going to need robotics. What do they need? They need the same kind of 4K type of link to be able to run at low latency to conduct activity. Oh, so I can just use that connection instead of it shooting back video content about rovers. I can do it basically as a link, a management link to run my robotics program, right? And then it just builds. So our estimate is the lunar surface from the time Commstar goes up is late 2023. From early 2024 to about 2027, roughly, our business model is landers, and more landers. 2025, 6, and 7, you get the buildup of robotics. But that first 3 years, it's megabits and high megabit range content and gigabit content. When the robots get there, it's petabytes and exabytes. And then it'll just take off after that. And so we are building a 15-year satellite. So we've got to build enough capacity in year 14 to address the comm needs of what we think is going to be there in year 14 of its useful life. So but at the same time, not to realize that we're planning for landers, which have a lower demand side. So that's the balancing act you have to play. But we've seen it now. We've seen it in the landers and the payloads, and this market, from a standpoint of communications market, is really going to take off.
Incredible. And with Commstar, you guys are parking at a Lagrange 1, and I know the average lifespan for a near Earth satellite is about 15 years. Due to the reduced needs of propulsion for station keeping. Would Commstar 1 actually be able to live past that 15-year mark?
We have an LOI with the bus supplier, Thales Alenia Space UK, and you usually put on your LOI your requirements and expectations. We have a 15-year useful life expectation. If it goes beyond that, then that's gravy. But for this business case, it's 15 years. Now, if you look 15 years out, or better yet, look 15 years back, that would be 1996. No, 15 years back, 2006. So 2006, there was no small sat industry. There was no SpaceX, really. There was none of this industry that we have now. So ironically, when people talk about, well, space is hard and it takes time, and it takes tons and tons of money, 15 years went like that. And another 15, which is 2038, 2040. If you listen to Elon's going to have a metropolis in Mars in 2040. He's going to have one of his long haul vessels going out, once a month. Carrying passengers and food and supplies, and ultimately bringing real things back. And then ultimately, Elon, and probably more Jeff Bezos than Elon, will realize the fortune to be made in habitation off planet, not at Mars, but near Earth, and also the fact that you make money by mining the asteroid belt. All those things have the same thing. Whatever we're doing now on the moon, I'll go back to transportation, communications, habitation, industrial development, the usage of products and services is the same business models that go to the asteroid belt, that go to habitations like Jerry O'Neill's projected habitations at L5, Lagrangian 5, and also going to Mars. And we did a customer survey last year of commercial companies. Thanks to the Space Foundation, we got 4,000 We sent out to 4,000 members of the Space Foundation. We got a really strong response, and they gave us what we consider is a solid feedback on where commercial customers, what they're interested in, what are they going to do over what time period, what do their business cases tell them, and what I've just told you in the last 30 minutes or so. It's transportation, communications, habitation, mining, industrial development, some travel and tourism. But the sub-plans underneath that are lava tubes turned into what would be industrial facilities, data centers, travel and tourism centers, hotels. Sounds silly in 2021. 15 years from now, it'll sound old school because it'll be there.
Incredible. Thank you, Bob. Incredible conversation with you. You shared a wealth of knowledge with us and the listeners. Who from the audience that's listening would you like them to reach out to you, and how could they reach out to you?
Pretty much anybody. I mean, our sense is obviously from the commercial standpoint, anyone who is in early stage planning or planning to return to the moon or provide goods and services around the moon, they're going to need comms. Context. So that's one group. Another group that we would really like to hear from, whether it's NASA, ESA, universities, high schools, the US government, is we carry a lot of capacity for hosted payloads. So if you have an interest and you're not going all the way to the moon, but you want to do things like situational awareness or PNT, advanced high-powered PNT, for example, positioning, navigation, and timing. If to turn Commstar into a beacon, not just a comm point, but also maybe a virtual digital lighthouse that people can lock into on their way to the moon, then we'd love to hear from you, because that's space that we can basically rent out, that excess space. The science agencies know who we are. The space agencies do as well. We and the Commstar team make a special effort to talk to high school and universities. I was just on a call with a university before this. Some programs, all we can do is give information. Other programs, we can actually talk about how we can help their program. Those are the future entrepreneurs. I don't know, unlike my generation, where you went out of school and you went in and, I was trained as a lawyer, you go to a law firm. Now, if you're in high school and you're working on a payload and you're thinking, you're 17 years old and you think, how do I get a ride? How can I get a ride? I want to get to low Earth orbit. Can my school help me contact somebody that can give me a ride? I have a shoebox size thing that I want to get in, and it's operating on 1 kilobit and it's on S-band or something, but I want to be able, if my class wants to put it up, and being able to help people find a ride, help people at that level means that guy is going to someday, he's going to be 23, 24 years old. He's got something bigger and he's still going, how do I get a ride? How can I get up there? And what's it going to cost me? So pretty much anybody. One of the things about space is it's really wide open. There are no barriers to entry from a standpoint of who's got basically the control over it. There are billionaires in it. There are monopolies that will attempt to be made, but right now it's kind of it really is it's wide open.
Absolutely. Space is one of the most inclusive, not exclusive, inclusive industries around. And from my own experience, everyone's willing to throw in a hand and help out and give back. So there's one of the millions of reasons why I truly love and have a deep passion for this industry. Mm-hmm. Bob Brumley, thank you very much for appearing on the show. It was an incredible conversation, and I wish to have you back again one point.
I appreciate it. Thank you for giving me the time. Thank you.
All right, everyone. That was a great episode with Mr. Bob Brumley from the Final Frontier podcast. If you want to catch up on past episodes, you can find us on Spotify, iTunes, literally any podcast platforms, as well as YouTube. Subscribe, like, send some suggestions. And if you think you'll be a great guest on the show, love to hear from you. Thank you very much. Bye.